Hello! Today we're going to be talking about descriptive statistics. In particular, we're going to talk about the mean and the standard deviation and calculate them. All right, let's go. Let's say a group of social workers make a certain income, and then a little bit less make a little bit less, a little bit make a little bit more, and then on the ends we have people who make a lot and very little. This is an income distribution. It can also look like this. In the middle of a normal distribution, you'll find the mean, the median, and the mode. How is this helpful? Well, let's say that you graduated and you just got a new job. Congratulations! And you're wondering, how does your salary stack up to those of your coworkers? To answer this question, we'll use the mean and the standard deviation. In a normal distribution, we measure the area under the curve in standard deviations. The majority of the data points will fall in the middle, in that green area. In fact, 68% of the data points will fall in plus or minus one standard deviation from the mean. The further out you go, the less likely the data point is to fall under that part of the curve. Remember our income distribution earlier? It would look like this when stacked against our normal distribution. So if we know the mean and we know the standard deviation, we can figure out where your income lies in relation to your peers. So let's say you start by asking 5 of your coworkers what they make, and they happen to tell you they make between $41,000 and $63,000. That would make an average income of $42,200 for your peers. This is the mean of the sample that you asked. So what good is it to know the mean? Well, if we know your salary, let's say it's $50,000, we can subtract the mean, and we quickly, by doing a little math, figure out that you're making $2,200 less than the mean income of your group. Well, that kind of stinks. But we don't know much about the shape of the distribution. Are all the incomes squished together, like on the left? Or is the standard deviation really large and they're really far and spread apart? So how much is $2,200 in relation to what all of your peers make? To answer that question, we really need to calculate the standard deviation. To calculate, we take each of your peers' salaries, subtract the mean, and we get a difference of the mean. If we were to just add this together, it would equal 0. So we square the terms, add those together, and we get a really large, giant number. Yes, that really is a ridiculously large number. That's because it's squared. It's called the sum of squares. If we divide by n minus 1 for the 5 employees, you get the variance. If we take the square root of that, remember because we squared earlier, we will get the standard deviation, 8,758 cents. Now, if we take your salary difference, $2,200, and divide by the standard deviation, we see pretty quickly that your salary is 0.25 standard deviations away from the mean. So you're pretty much making the mean salary in your group. In fact, here you'd be, right there in the green area, pretty close to the middle, considering you just got hired and just graduated. So to calculate the standard deviation, we calculate the mean, then subtract the mean from each data point, square the differences, divide by n minus 1, and then take the square root of that mean. That will give us the standard deviation. What does it look like? Well, you have this really complicated looking formula that actually isn't that difficult. The SD stands for standard deviation. Then we have the sum, the data points, the mean, and the number of data points. That's all you need to know to calculate the standard deviation. All right, that's it.